Welcome everyone. We are delighted to have you here today to explore genetic engineering. We will present a comprehensive introduction to genetic engineering, covering the techniques, applications, and ethical considerations of manipulating an organism's DNA to create desired outcomes. We hope you find this presentation educational and informative. Let's begin. Uncovering the fascinating world of genetic engineering. This presentation will explore the techniques used in manipulating DNA to create desired outcomes, as well as the applications and ethical considerations of this revolutionary technology. From revolutionizing agriculture and medicine to raising ethical questions, join us as we discover the possibilities and implications of this revolutionary technology. Genetic engineering is a tool that allows for precision changes of genes to create desired traits. It can be used to modify existing organisms or introduce new genes from one species into another, leading to the emergence of genetically modified organisms, GMOs. GMOs have the potential for numerous applications in agriculture and medicine, as they enable the control of genetics of plants and animals to create new forms of life with enhanced characteristics and yields. Scientists now have access to more refined and effective methods of genetic modification compared to former times. A notable example is the CRISPR Cas9 system, allowing researchers to cut and adjust chosen parts of DNA. This has enabled the creation of organisms whose DNA is subject to precise modifications. Other procedures, such as RNA interference and gene editing, utilize small RNA molecules and nucleuses so as to modify gene expression and affect exact DNA sequence changes. These highly capable techniques present a vast amount of potential opportunities in areas like agriculture, medicine, and other domains. Genetic engineering offers an effective approach to resolving some of the most pressing issues facing the world in terms of agriculture. Through increased crop yield, disease resistance and improved nutritional content, genetic engineering holds the potential to meet the growing demand for food, while simultaneously increasing food safety and quality, and reducing the environmental toll caused by the use of pesticidal and herbicidal substances. Additionally, genetic engineering can be put to use to tackle particular global health and nutrition concerns, like vitamin A deficiency, which can profoundly benefit millions of people globally. Genetic engineering has completely transformed the medical field, providing unprecedented ways to address genetic conditions and enhance healthcare. Replacing or fixing flawed genes through gene therapy and customizing treatments to fit each patient through personalized medicine are amongst the many opportunities made available. A prime example of the advancements in genetic engineering is mRNA technology, which was deployed in the Pfizer-BioNTech and Moderna COVID-19 vaccines. As research in this field continues to evolve, we can anticipate more medical achievements being enabled by genetic engineering. As we enter an era of unparalleled scientific comprehension of our world, the moral ramifications of genetic engineering must be thoughtfully taken into account. Organizations making attempts to attain desired effects by tampering with an organism's DNA necessitate that we look at the likely unforeseen implications. We must remember the likelihood of the malignant application of such technology, for example in the fabrication of bioweapons, and safeguard that any laws or rules set in place are designed to flaunt responsible and ethical practices. It is critical to the success of any scientific pursuit that we take into consideration the moral consequences of our research and decisions. Genetic engineering provides the potential to transform our attitudes towards food production and healthcare. It can be used to modify genes in crops and livestock, providing a range of benefits for the environment and people alike. For example, genetically modified crops may have higher yields, increased resistance to disease, and greater nutritional value, which can help us create more durable and dependable food sources in order to sustain a rising global population. In healthcare, genetic engineering is also presenting a large amount of promise. Multiple research initiatives are being instigated to devise personalized medicines and gene therapies, with the aim of targeting certain genes associated with diseases, providing an opportunity to potentially treat or prevent them completely and thus greatly improve the quality of life worldwide. potential of genetic engineering to improve agriculture and medicine cannot be denied. However, potential risks associated should be assessed. Unanticipated impacts of modified crops on its surrounding ecosystem should be evaluated. Misuse of genetic engineering for unethical objectives such as creating designer babies or artificially boosting capabilities should not be overlooked. Thus, it is critical to ensure ethical discussions are placed in priority for the responsible use of this technology. Regulation of genetic engineering plays an essential role in ethical growth and proper application of the technology. In the U.S., the Food and Drug Administration and Environmental Protection Agency oversee safety of products made from genetic engineering. In order to safeguard human health, animal welfare, and the environment, these regulations guarantee that products developed with genetic engineering are subject to extensive safety tests and evaluation prior to their release. Public awareness and understanding of genetic engineering may be low, but that does not mean that the technology is something to be feared. While it is true that unregulated genetic engineering can have negative consequences, with proper oversight, it can be used to address a range of global issues. Scientists, policymakers, and the public should work together to ensure that genetic engineering is employed safely and responsibly. Education and open dialogue are key to fostering trust and a more informed public opinion. Golden rice is an example of genetic engineering, designed to produce beta-carotene to address vitamin A deficiency in developing countries. Developing golden rice has been controversial, with some arguing it may have unintended consequences. However, it has been proposed as a more sustainable solution than traditional methods, such as supplements and fortification, for addressing vitamin A deficiency. CRISPR-Cas9 is a powerful tool for gene editing that allows for exact, planned changes to the DNA of an organism. In 2018, Dr. He Jiankui caused a significant controversy when he declared that he had utilized this technology to genetically modify the embryos of twin girls to make them resistant to HIV. This experiment raised considerable ethical qualms. Gene editing presents the possibility of unanticipated mutations and unforeseen alterations to the genome as well as impacts on descendants if genetic engineering is widely adopted. As we progress onward in this technological age, it is essential that we thoughtfully consider the moral implications of our choices. Genetic engineering has revolutionized agricultural practices, particularly with the development of Bt cotton. This genetically modified variety of cotton contains genes from the soil bacterium Bacillus thuringiensis, producing a protein that is toxic to the bollworm, a common pest. This allows farmers to reduce their usage of harmful pesticides, thus increasing crop yields. Since its introduction in India in 2002, Bt cotton has had a profound impact on the country's agricultural industry, providing economic benefits but also having some unintended consequences. These include the higher costs of the seed and fertilizers, and the potential for the development of resistance as pests are eliminated. Cases of farmer suicide have been linked to increased costs and lack of access to traditional agricultural knowledge. These cases illustrate the importance of taking into account potential implications of genetic engineering. As more applications are discovered, ethical principles must be applied to ensure its safe and responsible implementation. Scientists are increasingly finding new methods to alter and manipulate genes. These discoveries could have a major impact on our lives and the world around us. For instance, through gene editing, it may be possible to get rid of mutations that cause diseases in embryos. Such a development could bring an end to certain genetic ailments, while also raising ethical and social considerations, such as who chooses which characteristics are desirable in the threat of a genetically superior class. Also, the prospect of modifying physical or mental aspects brings up new ethical questions. Although it may sound like something out of a sci-fi movie, this is not too far off from being achievable. Genetic engineering has the potential to drastically change science, medicine, and agriculture. For us to use it responsibly, public engagement is of utmost importance. We must make sure that everybody involved is aware of the situation and has a say in the development and regulation of genetic engineering. Consultations, community meetings, and online forums are all effective ways of ensuring that any risks and unintended outcomes are avoided, and benefits are maximized. Moreover, the public engagement needs to be meaningful and accessible. Genetic engineering is a field of science that requires collaboration between experts, policymakers, and the public to be developed responsibly and ethically. As scientists, it is our duty to conduct comprehensive and open research, while policymakers must make laws that find the right balance between innovation and public protection. The public plays a vital role in providing input and participating in debates regarding the potential advantages and drawbacks of genetic engineering. The joint effort of all these stakeholders is vital for the responsible and ethical advancement of genetic engineering. By working together, we can recognize potential solutions, technologies, and regulations that can benefit society in a sustainable and ethical manner. The field of genetic engineering is a rapidly evolving area of science that requires individuals to be educated on the science behind it, as well as the potential risks and benefits. Educating individuals on these topics can also aid in developing critical thinking skills and help to promote productive, open dialogue about the development and regulation of genetic engineering. Through collaboration and open communication, we can ensure that safe and ethical use of genetic engineering is prioritized and that its potential benefits are realized. Ultimately, this will help generate understanding and guide informed decision-making when it comes to genetic engineering.